Okay, so now we're on to question number 12, which is a multi-step question. So we have acetone or propanone has a density of 0.786 grams per milliliter, and the heat of combustion is 428 kilocalories per mole. Part A is to write the equation for the complete combustion of propanone. B, how much heat in kilojoules is released if 2.58 grams of propanone reacts with oxygen. C, how many grams of oxygen gas are needed to react with 15 milliliters of propanone. And D, how many liters of carbon dioxide are produced at standard temperature and pressure in part C. Okay, so this is multi-step, and it's a very good question because it covers a lot of different topics. So first, let's try to tackle just the first question, which is to write the equation for the complete combustion of propanone. So to answer this question, we need to first know the structure of propanone so that we can balance it. So propanone, if we analyze the name of this compound, it has a prefix of prop, which tells us that there are 3 carbons in the parent chain, and we know that it ends in -one, so that means the middle carbon will contain a ketone group, which is that double bonded oxygen, and then the rest of the bonds of the other 2 carbons will just be filled with hydrogens. Okay, so this is the structure of propanone, and if we were to write out its chemical formula, it would be C3H6O. Okay, so now that we have the chemical equation and we have the structure, when we have a combustion reaction, this means that the propanone will react with oxygen, and the products that are formed are water and CO2. Okay, so this is a combustion reaction, and now we just need to balance out all of the atoms. So let's do carbon first. So carbon, on our reactant side, there are 3 carbons, so we just need to put a coefficient of 3 in front of CO2. And now let's balance out the hydrogens. So we have 6 hydrogens in propanone, so we just need to put another 3 in front of H2O. And at this part, I like to now balance my oxygens, and I do it last because if I were to balance it first, then it would, once we start balancing the hydrogens and the carbons, then the numbers will all change and we have to redo it. That's why we balance oxygen last. So on our product side, we have 3 plus 6. So that is 9. And we already have 1 oxygen in propanone, so we need 8 more. So we just need to put a 4 in front of O2 to balance out the equation. Okay, so this is part A. We have our balanced chemical equation for the complete combustion of propanone. Now for part B, we need to know how much heat in kilojoules is realized if 2.58 grams of propanone reacts with oxygen. Okay, so to answer this question, we just need to do some calculations. So we know the mass of propanone is 2.58. And they gave us in the question that the heat of combustion is 428 kilocalories per mole. So let me write that down. Delta H of combustion is equal to 428, and the units are kilocalories per mole. So to calculate how much heat is going to be realized, we need to find out the number of moles in 2.58 grams of propanone. So let's recall that to calculate for number of moles, it's going to be mass over molar mass. So to find number of moles, we need to first find the molar mass of propanone. So we can do that down here. We know that the molar mass is going to be 3 times the molar mass of carbon plus 6 times the molar mass of hydrogen plus just the molar mass of oxygen. So we can find these different molar masses on the periodic table. So for carbon, it's 12.01 grams per mole. And for hydrogen, it's 1.01 grams per mole. And for oxygen, it's 15.99 grams per mole. So now if we add these all up, we get a final molar mass of 58 grams per mole for propanone. And now we can find the number of moles. So number of moles is mass over molar mass. So it's just going to be 2.58 grams divided by 58 grams per mole. So now we get a number of moles of 0.44. Now that we have our number of moles, we can solve for the heat. So heat is equal to the number of moles, which is 0.44, times the delta H of combustion, which is 428 kilocalories per mole. And then we end up with 19.04 kilocalories. So the moles will cancel out. And to convert to kilojoules, we just need to multiply by the conversion factor, which is 4.184 kilojoules per kilocal. So now our final answer is 79.66 kilojoules. Okay, so that's part B. Part C, how many grams of oxygen gas are needed to react with 15 milliliters of propanone? So they give us the density of propanone. So part 1 of this part C is to first find the mass of the propanone in 15 milliliters. So if we recall that density is equal to mass over volume, then we can rearrange this equation to solve for mass, which is density times volume. And the density was 0.786 grams per milliliter, and the volume was 15 milliliters. So this gives us a mass of 11.79 grams of propanone. I'm going to do it in a different color just so that it's more organized. But for the second step, we're going to find the number of moles of propanone. And again, we do number of moles is equal to mass over molar mass. So it's 11.79 grams. And we know the molar mass already is 58 grams per mole. So now to calculate for number of moles, we end up dividing and get 0.2 moles of propanone And from there, we can also calculate the number of moles for oxygen. I'm just going to add that here. Then use mole ratio. So because we already balanced our equation, we know what the mole ratio between propanone and oxygen is. So we know that 4 moles of O2 is needed to react with 1 mole of propanone. So we just need to multiply 0.2 by 4. And we end up with 0.813 moles of oxygen. And now step 3 of part 3 of this question is just to find the mass. Find the mass of oxygen. So now mass is equal to number of moles times molar mass. Number of moles we found in the previous step to be 0.813 moles. And the molar mass of O2 is 32 grams per mole. So we get a final mass of 26 grams of oxygen needed. Okay, so let's start a new page and answer part D. Which is how many liters of carbon dioxide are produced at standard temperature and pressure in part C. Okay, so when we have standard temperature and pressure, that means that the temperature and the pressure, they're all constant. So the only thing that changes or that varies for this reaction would be the volume and also the number of moles. So at STP, the molar volume value is 22.4 liters. So at standard temperature pressure, volume is equal to 22.4 liters. And also number of moles is equal to 1. So we can just multiply 22.4 liters by the mole ratio of 3 moles of carbon dioxide. And we got that from the balanced chemical equation. There are 3 moles of carbon dioxide for every 1 mole of propanone. So 22.4 liters times 3 is equal to 67.2 liters. Okay, so now let's see what the junior tutor said. Step 1 is to write the equation for the complete combustion of propanone. And let's go back to mine. We have C3H6 plus 4O2 makes 3 CO2 plus 3 H2O. Step 2 is to find the heat in kilojoules of propanone. So they calculated molar mass to be 58. And then they just showed how okay, yep, so they showed that 58 grams. It's another way of showing that 58 grams of the propanone will produce the 428 kilocalories per mole. So 2.58 grams of propanone produces 19.04 kilocalories per mole, which is also around 80 kilojoules. Step 3 is to find the mass of propanone in the 15 milliliters. So they got 11.79. And then by using molar ratios, calculate the mass of oxygen. Yep, so they also got 26 grams. And then step 5, find the liters of carbon dioxide. We have 3 times molar volume, which is 22.4, and they got 67.2 liters. Okay, so this solution is correct. Let me just read this question again. Yep. I think I'm also going to answer part D using 15 milliliters of propanone. So the 22.4 is if it were like the molar volume of a gas. But if we did have 15 mils of propanone, no, I guess that's correct. Yeah, the solution is correct. Then I'll just add a note. Molar volume is equal to 22.4 liters. So which is why 67.2 liters of CO2 is produced.